Welcome to the session about concurrent programming. So in this session we look into semaphores, Java semaphores. So the aim of this session is to introduce the concept of semaphore, so which is binary and the general. And after that we'll be describing the semaphore operations: initial, claim and release. So next we present an overview of Java semaphore class, and we have a small demonstration as well which showcase the functionality of semaphore, a particular scenario. So using semaphores to achieve ordering of the actions of processes, mutual exclusions and conditional synchronization. So semaphores are used to solve the concurrency resource sharing problems. So in the previous sessions we discussed about the dining philosopher problem, and we found that the resources are limited. So dining philosopher problem is you have a table and you have several people, and in between them they have a fork. So a particular philosopher should have one on the left and one on the right to have the meal. So the resources are limited. So resource sharing is discussed there. Producer consumer problem, readers and writers problem. So the semaphore mechanism, it's by Edgar W. Dijkstra's in 1968. So invented by Dijkstra during research into operating systems in mid 1960s. So let's see what is a semaphore. A semaphore is a program language mechanism that is used in concurrent programming to achieve the following: to resolve race conditions, achieve mutual exclusion, achieve process synchronization and coordination. By combining these basic elements together, a programmer can ensure that a collection of concurrent processes safely share resources and coordinate their activities. So a collection of concurrent processes can safely share the resources, and also a particular coordination is required in order to handle the situation. Semaphores were first specific and most primitive form of synchronization mechanism introduced in programming languages to achieve these tasks. So in here we looked into a semaphore. It's a programming language mechanism that is used in concurrent programming to achieve resolving race conditions, achieve mutual exclusion. So critical part should be achieved by only one piece of code, achieve process synchronization and coordination. So semaphore is something like a special kind of a lock. So you can think of a semaphore as a special kind of lock. So it has operations locked or unlocked. So it's a special kind of lock that has operations that allow it to be either locked or unlocked. So definition of a semaphore. Let's see a definition of the definition of the semaphore. A semaphore is an integer variable that can have only non-negative values. Is an integer variable that can have only non-negative values. So s greater than or equal to 0. So there are two types of semaphores: binary semaphores and general semaphores. Binary semaphores can only have the values 0 or 1. A binary semaphore is also called a mutex from mutual exclusion. So binary semaphore is also called a mutex. General semaphores can have any value greater than 0. However, general semaphores are almost and always defined to have a maximum value that must not be exceeded. A general semaphore is called a counting semaphore. A general semaphore is also called a counting semaphore. Binary semaphore is called a mutex. So let's see the definition of a semaphore again. A semaphore is an integer variable that can have only non-negative values. So there are two types of semaphores: binary semaphores and general semaphores. Binary semaphores can only have the values of 0 or 1. So binary semaphore is also called a mutex. General semaphore that can have any value greater than 0. However, general semaphores are almost always defined to have a maximum value that must not be exceeded. A general semaphore is also called a counting semaphore. So if you see the Oracle documentation, a counting semaphore, conceptually a semaphore maintains a set of permits. Each acquire blocks, so you can see the operations. So we'll look into these operations in our demo code. Some of these operations: acquire, release. Acquires a permit from this semaphore, blocking until one is available. So releases a permit, returning it to the semaphore. So you have several constructors. Here two constructors. One is public semaphore in permits, creates a semaphore with a given number of permits, and non-fair fairness setting. So parameters permits the initial number of permits available. This value may be negative, in which case releases must occur before acquire will be granted. So creates in the next constructor permits, and boolean fair is also there as a parameter. Creates a semaphore with the given number of permits and the given fairness setting. So let's see this fairness setting. Fair true if this semaphore will guarantee first in first out granting of permits under contention, else false. So semaphore is like a special kind of lock. So generally semaphores used to control resource access should be initialized as fair in order to ensure that no thread is starved out from accessing resources. To provide fairness, you have fair. So semaphore operations: claim, lock a semaphore s dot claim, so s dot acquire, wait. So it has three operations: claim, release and initialize. Claim is to lock a semaphore, release is to unlock a semaphore using s dot release, and then initialize. So let's see the demonstration about claim, release and initialize. So we saw the methods available in the documentation. Let's see. Found an example here from so if you look at this code, we have a public class semaphore demo, and we'll allow max for 4 semaphores, 4 instances. So we have a static class here, class myThread, which extends the thread, and inside the run method we have system.out.println name, and it prints acquiring the lock. And next, available semaphore permits. So we'll create the semaphore here, and semaphore dot available permits. So once we create an object of the semaphore class, you can see dot available permits, and after that inside the run method it acquire the lock, and once the permit is given, got the permit, it prints got the permit, and name is performing operation, so which semaphore, which permit, and the balance number of permits available. So it happens like that. And once the method is invoked, finally once the task is done, the acquired lock is released and the number of permits are printed. So here we create 6 threads and start them. So this is the main method. First we print the number of permits, And so let's run this example. So you can see total number of permits 4, and here it acquires the lock, prints this one. Available number of permits acquiring the lock, so still it has not acquired the lock, trying to acquire the lock. So we have the full number of permits 4, and once the here we acquire the lock, semaphore dot acquire, and next we print got the permit. Yes, now we have got the permit, and A is performing operation 1. So thread is A is performing operation 1, and now available number of permits. So now 1, due to this semaphore dot acquire, now we have given 1 away, so we have balance 4 minus 1 3. So it prints available semaphore for permits 3. And the B got the permit, and B is performing operation 1, and now another permit is given. So now the available permit is reduced by 1, now it's 2. So it happens like that. So when the available semaphore permits are 0, so the actions occur like that, because you can see E is acquiring the lock, E is trying to acquire the lock. Now we have only 4 semaphores, A, B, C, D. 4 instances have acquired it. Now we don't have anything. So A, B, C, D, E. The fifth one is trying to acquire the lock, acquiring the lock. Available number of permits is 0, acquiring the lock, but still it's not possible. The available number of permits are 0. So D, E and F cannot acquire the lock. So we have to wait until A, B, C, D or from one, either one from A, B, C, D release it. So when one particular thing is released, then E or F can acquire it. So the A, B, C, D successfully continues. And now we can see C is releasing the lock. So in the finally method we print releasing the lock, semaphore dot release. So C is releasing the lock and B is also releasing the lock. Now available semaphore permits 2. Available semaphore permits 2. A is also releasing the lock. So E and F, now they have got the permit, because the previous instances have they have released it, so E and F has taken it. So it happens like that. So you can look at this code and download it. You can type this code, set it up this example, execute it, and watch carefully how it is done. So it is recommended to watch this video again and again, so you can clearly identify the operations or the situation which is related to a semaphore. A semaphore is explained here with a clear demonstration. So this is the code which is available. So you can type this code. So you can change the number of semaphores. So if it's so this is general semaphore. If it's a binary semaphore, it is 0 or 1. So it's a mutex. So this is a counting semaphore. So you can see the semaphore operations: semaphore.acquire, semaphore.release, semaphore.available permits. And the output. That's the end of the session.